Average molar kinetic energy of carbon monoxide and nitrogen at same temperature is. Here temperature remains same. Okay. Kinetic energy of gaseous molecules depends on only temperature, not masses. Okay. If temperature is remains same, then kinetic energy also remains same. Okay. If temperature is constant, there is no change in the kinetic energy of gaseous molecules. When kinetic energy of carbon monoxide is equal to kinetic energy of nitrogen at same temperature. Temperature remains same, then kinetic energy of the gaseous molecules also same, and kinetic energy is independent of mass when temperature remains same. Okay, note on this. At 25 degrees Celsius and 730 mm pressure, 380 ml of dry oxygen was collected. If the temperature is constant, what volume will the oxygen occupy at 760 mm of pressure? At constant temperature, the pressure and volume, this relation given by which law?
Boyle's law.
Okay. So according to Boyle's law, pressure is inversely proportional to volume. So PV equal to constant. From this we can write P1 V1 equal to P2 V2. Here P1 value 730, V1 value 380, P2 value 760. Then you have to find the V2. Here pressure increases, volume decreases, right? How much it is? So P1 V1 equal P2 V2. Then V2 we can write as P1 V1 by P2. What is the P1 value? 730 into V1 value is 380 by 760. 0 0. Otherwise you cancel this 0. 38 how many times it is? 2 times. 2 3 just 6. 2 6 5 times. Okay, V2 equal to 365 ml. When pressure increases, the volume occupied by the gas decreases from 380 to 360. Okay, your answer here B is matching. The following statements is wrong for gases. Confined gas exerts uniform pressure on the walls of its container in all its directions. This is correct. Volume of gas is equal to volume of container confining the gas. This is also correct. Gases do not have a defined shape and volume. This is also correct. And mass of gas cannot be determined by weighing a container in which it is enclosed. But this is wrong. We can determine the mass of the gas, but here given cannot be determined. This is wrong statement. So we have to select the wrong statement here. The option is D. Okay. You want to write this?
Yes.
The average kinetic energy of an ideal gas per molecule in SI units at 25 degrees Celsius will be. The kinetic energy per molecule, what is the formula? 3 by 2 RT per molecule means you have to take Avogadro number here by N. Okay, 3 by 2. What is the R value in joules? That is 8.314. Into temperature you convert into Kelvin. So temperature 25 degrees Celsius convert into Kelvin 273. How much it is? That is 298 Kelvin. Use temperature here 298. And what is the Avogadro number? 6.023 into 10 power 23. Just I am making round figure. It is 6 into 10 power 20. 23. Okay. So 2 how many times it is? 2 on the 2. 2 4 the 8. 149. Right. 3 how many times it is? 2 times. Okay. 2 how many times it is? 2 4 the 8. 2 on the 2. Right. 11. 4.157 into 149. So make it round figure like this. 4 into 150. 15 4 ja. In 10 power 10 to 3 you take it up. This will become 10 power minus 23. 4 into 150 into 10 power minus 23. And make it round figure. 4.15 you write as 4. 149 you write as 150. 15 into 4 how much? 60. 0 is there. 600 into 10 power minus 23. You remove these 2 zeros with 10 power minus 23. It will become 6 into 10 power minus 21. Okay, so your answer which one is matching?
D1.
Answer is D. At what temperature the rate of effusion of nitrogen would be? 1.625 times then the rate of SO2, sulfur dioxide, at 500 degrees Celsius. Okay, the rate of effusion depends on your molecular weight. So if molecular weight is more, rate of diffusion is less. Okay, and also it depends on temperature. If temperature is more, rate of effusion also more. So gas moves very speed. If rate of effusion or diffusion is inversely proportional to square root of mass and directly proportional to temperature, when you combine these two, you will get this. Rate of effusion is directly proportional to T by root over m. Okay, so when you do like this, R1 by R2 equal to, so T1 by T2, it is in the directly related, so that you can write T1 by T2, right? But it is inversely related, so this will become root over 1 by 2 will become here 2 by 1, m2 by m1. Okay, and given, what are the given things we have here? The rate of effusion of first gas is how many times of more than the second gas? 1.625 times of second gas. Means rate of effusion of first gas, that is a nitrogen gas, which is equal to 1.625 times of the rate of effusion of second gas. Okay, so from this, can I write R1 by R2 equal to, how we can write this? R1 by R2 equal to, into R2 you take it this side, so this will become 1.625. Okay, so in the place of R1 by R2, just you substitute here 1.625. Okay, in temperature 1, how much they given, we don't know. We need to find this T1, we need to find. And second temperature of second gas is how much here? 500 degrees Celsius. This 500 degrees Celsius, just you convert into Kelvin. 500 degrees Celsius when you convert into Kelvin, so what will you get here?
773.
So R1 by R2 is 1.625 and we need to find the T1. So T2 means here 500 plus 273. How much it is?
773.
773 into root over. What is the molecular weight of sulfur dioxide? Molecular weight of sulfur dioxide. Sulfur atomic number is 16. Its atomic weight is 32. Plus here we have 2 oxygen. Oxygen atomic weight is 16. 16 into 2. 32 plus 32. 64. Then nitrogen atomic weight is 14. 14 into 2. 2 atoms are there, right? 28. Okay, so M2 here, M2 indicates SO2 molecular weight, M1 indicates nitrogen molecular weight. Second gas is SO2, right? So that is 64 by 28. Okay, so do the calculation this. So you T1. So this is what? T1. Do it. So your temperature is 773 Kelvin. So R1 by R2 value we got here how much? Yes, all of you please see here. Don't. R1 by R2 value is 1.625. We need to find the temperature T1 value. T2 value is how much? What is the T2 value? T2 value is 773. So root over, this is the molecular weight of SO2 by molecular weight of nitrogen. What is the weight of SO2? Yes, just now we calculated how much it is? 64, and nitrogen molecular weight is 28. Okay, so 1.625 into 773 equal to T1. Root 64 value is 8. This 28, root 28, how we can write? Can I write 7 into 4? Root 4 value is how much? 2. This is 2 root 7. So 8 by 2 root 7. Just you do here. So T1 equal to 1.625 into 773 into 2 root 7 by how much? 8. Okay. So 8 how many times? 0.2 times. So 0.2. This 773 you make it round figure 770 into 2. Already you know that root 4 value is 2, root 7 value, root 9 value is 3. Then root 7 value lies between 2 and 3, and it is nearer to 3, right? 2.7. Okay, this I can write 0.2, make it round figure like this, 770, and 2 into 2.7 is 5.4. This you make it round figure as a 6. Okay, 6 into 0.2 is how much? 1.2 into 770. This we can write as 12 into 77. Okay, so 12 7 ja 84, 12 7 ja 84 plus 4. 884 Kelvin. Okay, so then how do you get in degree Celsius this?
-2.
884 Kelvin convert into degree Celsius. T degree Celsius. 884 minus 273. 4 minus 3 is 1, 8 minus 7 is 1, 8 minus 2 is 6. 611 degrees Celsius, and it is matching with the answer. Gases does not obey the Dalton's law of partial pressure, and Dalton's law partial pressure is applicable for only non-reacting gases. And now you see chlorine and SO2 they given, and carbon dioxide and helium, oxygen and CO2, and nitrogen and oxygen. Nitrogen is an inert gas, it did not react with the oxygen, and there is no reaction between oxygen and CO2 also. And helium is an inert gas and it won't react with the carbon dioxide. Okay, and but these two gases react with each other. So chlorine plus SO2 and react each other and form SOCl2, sulfonyl chloride. Okay, then Dalton law partial pressure is not applicable for this mixture. Okay, these two gases are reacting with each other. Okay, this is your answer.